Hey, welcome back. Today is actually Tuesday, January 19th, 2021, and it's been a few days since I've seen you, so I hope that all is well, and I hope that you guys enjoyed your long weekend. You know, on Friday, we had an e-learning day, which meant there was no video from Miss Trammell. And then on Monday, it was Martin Luther King Jr. Day, so there was no school. So that means we have not been able to talk about the calendar markers from those days. So we're going to do that very quickly now. We're going to update our calendar collector, and then we have a problem string to work through today. So let's take a look at what the calendar markers look like for the days where we were not physically in school because it was the weekend, a holiday, or for our e-learning day. So January 15th, triangle. 16th, big triangle. 17th, ooh, what is the 17th? That looks like an interesting shape. What do you think that is? Can you see it? I know this thing is in the way. Maybe I should go to a different screen so it'll give you a really good view of what it looks like. It almost looks like a triangle, but it has 4 sides. What do we call a 4-sided shape? Yeah, we call it a quadrilateral. 4-sided shape is called a quadrilateral. So this is a quadrilateral, and this is a big one, as my 2-year-old sometimes says. So quadrilateral, quadrilateral, and then we are at today, which is the 19th, and it looks like we have a pentagon, right? A pentagon is a 5-sided shape. So let's get ready to fill in our shape names, the area, and we can discuss any observations that you may notice with these shapes. So I'm going to write triangle, if I can spell the word correctly. And then we had triangle. And then we had quadrilateral. And then we had a quadrilateral. And then today is a pentagon. All right, so let's figure out the area for this triangle. So we have about 3/4, another 3/4, and then the so 3/4, 3/4, 1/4, 1/4, which would give us 2 holes. And then if you think back to our pattern from earlier, I believe that the second shape was always 4 times that of the first. So let's double check that. We would think that it would be 8, right? So let's check. 1, 2, 3, 4. And then this would be 5, 6 if you include this whole thing together because it looks just like what we saw yesterday. And then we have a piece here and a piece here, which would be 7 and 8. So it does follow the same pattern. Let's look at the 17th. We have 1 hole. And we had some funkiness looking here, but this is a 3/4 plus a 4th. So that's 2 holes and a half. So 2 and a half for the 17th. And if we think about 4 times that, that would be 2 and a half, 2 and a half, 2 and a half, 2 and a half, 2, 4, 6, 8. And then we have a half plus a half, which is a whole. So 9, half plus a half, it's a whole, so 10. So we would think 10. Let's check. 1, 2, 3. This would be 4, 5, 6, 7, 8, 9, and half plus a half is 10. Right? And then the last one is a pentagon. This is 1 whole, half plus a half is another whole, plus another half. So we have 2 and a half here. Just like we had on the 17th. Awesome. All right, now we're going to update our calendar collector. I will say that even though we didn't have school where you saw Miss Trammell on video, we still count that as a day of school. So today I'm going to add our 3/4 a day for day 10 and our 3/4 a day for day 11. Okay? You with me? Awesome. All right, so day 10, we added another 3/4. So 10 times 3 is 30. It gives us 30/4. So how do we simplify that? What's 30 divided by 4? What times 4 gives us a number close to 30? Right, 4 times 7. 7 times 4 is 28. And then what do we have left over? Or our remainder. We're going to talk a little bit about remainders today. Yeah, 2/4, or I'm going to write that as 1/2. And we already know that when there's a half there, that means we have 50 cents. So we have $7.50 from our 10th day of school. And now we're going to do our 11th day of school, which is here. And that's 33/4. 33 divided by 4. 4 times 8 is 32. And then we have 1/4 left over, which we know that 1/4 is 25 cents. So that is our calendar collector for today. Now I want to jump into our problem string, and I'm going to give you some context. So we're going to be talking about packs of markers, and we're going to be thinking division. But this time, we're going to use a ratio table, okay? So let's just say that there are 8 markers in a pack, and that's going to help us figure out the answers to the remaining questions. You may also see that this first question here is multiplication. So I want to remind you that every time we've done a problem string so far this month, we've talked about the relationship between multiplication and division. So hopefully us knowing 10 times 8 will help us solve the problems that will come up later. So let's solve that. 10 times 8, I know we can do that very easily. What is 10 times 8? Good, 10 times 8 is 80. And since we're going to be using a ratio table, I'm going to draw out a ratio table to help us see and think about what's going to happen next in our problem string. So I'm going to do that. You guys make sure you have your notebooks opened to the back of your number corner journals so you have space. Label it problem string 15. We've already done the first one, and we're going to get ready to do the second one after I draw my ratio table. All right, are you guys ready? All right, here we go. Let's look at the next problem. 80 divided by 8. 80 divided by 8. There are 80 markers. How many packs is that? Well, we know in one pack, so maybe I need to label this as P for packs. And then M is going to be for markers. So in one pack, we have 8 markers, and they're asking how many packs is it if we have 80? So if I were to fill in 80 here, and hopefully we can use what we just did with our first problem, 10 times 8, then we know that this is going to be 10. Because, and sorry, my automatic lights just went off, but now they're back on. So the relationship between this is that if I multiply by 10 here, that means I also have to multiply by 10 on the bottom. Right? Do we remember that when we talk about ratio tables and relationships? So this relationship helps me easily see that if I have 80 markers, that means I have 10 packs. Okay? And 10 times 8, because the relationship going this way is multiplying 8, is 80. Are we good with that? All right, let's look at the next one. 6 times 8. Oh, we can do that, and we can use our same ratio table here. So I know I have 6 packs. I want to know how many markers do I have. So this is me multiplying times 6. Really, I don't have to label this because this looks like our original problem. And then I'm multiplying 8 times 6. What is 8 times 6? Oh, I hope that you know 8 times 6. Please tell me you know your multiplication facts. Yes, 8 times 6 is 48. So how many markers are in 6 pack? 48. The top number represents how many packs, and the bottom number is representing how many markers are in each pack. Let's go to the next problem. Ooh, 128 markers. 128 divided by 8. If I have 128 markers, how many packs can I fill? That means we know this part of our ratio table. What we don't know is how many packs. So I could put a question mark here because I don't know it and we need to figure it out. So I am going to draw an area model and I want you to draw it as well. Okay? We know one side length, which is 8. So if we think back to what we did the other day, then we can draw our one side length. So that's 2, 4, 6, and 8. And I need to fill this space with 128 of these little squares. Okay? What do I know already from our ratio table? I already know 8 times 10. So maybe I can go ahead and fill out my times 10, which is here. And I know I'm not done yet, right? Because 8 times 10 is only 80. So in this space right here that I've drawn so far, I have 80. And we know 8. We're trying to figure out what is the answer. What goes up here? This is 10. Well, how much more do we need? 128. 80, 90, 100, 110, 120. So that's 48. Oh my gosh, look what I see right here. I already know what times 80 equals 48, which is 6. So I can add 6 to this. And that's 48, which gives me a total of 128. Right. So then what's the answer? What's my other dimension? 10 plus 6, which is 16. And I'm going to erase kind of some of these arrows that I've drawn here just to show you what happened between those two numbers. What did I do with 10 and 6? I used what I knew on the ratio table. And yes, I added them together. So I know 10 plus 6, which means I had to do 80 plus 48, which I represented in our picture right here. Does that make sense? Yeah, so what is our answer? Right, 16. You guys are doing awesome. Here we go. Next one. Ooh, now I have 136 divided by 8. How many packs can I fill? I'll give y'all a second to think about it. I will say we do know this. We're trying to figure out this. So take a moment, pause this video, and work it out. All right, did you realize that 136 is only 8 more than 128? So essentially, I just added one more pack. I added a pack, so now I have 17 packs. And if I add a pack, how many markers am I adding? Right, I'm adding 8 markers. So what's my answer? How many packs can I fill with 136 markers? Right, I can fill 17 packs. All right, let's keep it moving. Let's see what else we got. Ooh, 160 divided by 8. 160 divided by 8. Let's work it out. Right. If you haven't already noticed, we're going to use what we've already done on our ratio table, and I'm going to redraw it down here. 160 is 80 doubled. Okay, so essentially, this is what I'm doing. Here's what's happening. I'm multiplying 80 by 2, which gives me 160. And if I multiply 80 by 2, then that means I'm doubling the amount of packs that I have. So that means I have 10 times 2, right, which is 20. So then how many packs can I fill? I can fill 20. If I didn't know that, then I probably would have started with drawing this picture right here. And when I would have said, oh, I already have 80. How much more do I need? Oh, I need 80 more. So that's double. So if you had to draw a picture to solve that problem, that's perfectly okay. But I also want to show you the relationship of what happened. 80 doubled is 160, so I'm doubling 10 to have 20 packs. Since the question asks how many packs. And now the question says, I have 168 markers. How many packs can I fill? Well, just like earlier, how do I get from 160 to 168? Hey, I'm just adding 8 more markers, and 8 markers are in how many packs? Great, I'm adding 1 pack. So I have 21 packs now. 21 packs. So hopefully what you're noticing is that we can use the ratio table. That'll help us show these partial quotients, which is what Ms. Janelle has drawn here when she drew the area model. We figured out what we knew and we added on to it until we got our total area that we were given. Okay, that's known as a partial quotient. So we're using ratio tables today to show you a different way to record our thinking, because the other day we just used the area models. Okay, we have 2 more problems. And this next problem is going to be interesting. It says 184. Well, maybe not this one, but the next one. 184. So let's think. Let's say I had a picture drawn of an 8 by 21, which was 168. How much more would I need to go or fill in to give me 184? I'm going to draw a very quick model, and this is not to scale. So you're going to have to bear with me here because I know I don't have enough space to do this. But let's just pretend that this was 168, right? And we know that that's 21. And I'll write 21 down here for space purposes. Okay, we're just kind of pretending here. How much more do I need to add to get 184? 168? 178? Yeah, 16. I need to add 16 more, which might look something like this. And what times 8 gives me 16? 2. So I'm adding 16 now, which means I'm adding 2 packs. So instead of having 21 packs, I now have 23 packs. You got it. Now we have one more problem. And I know I said something about talking about remainders today. So let's talk remainders. 84 divided by 6. Now it says I have 84 pencils in packets that each hold 6 pencils. How many packs can I fill? Yikes. I'm going to clear my work here. I'm going to start over. And we're going to work this problem out. And we're going to start with a ratio table. Okay, and I'm going to do this as quickly as I can, so it may not be perfectly straight. I know in 1 pack, I have 6 pencils, so we change the context a little bit. And I want to know how many packs would be in 84 pencils. So let's just think about what we know. We might not know what times 6 would give us 84, but we know tens. Tens we should know really well. And we know if I were to multiply by 10, that would be 60. And then I have 24 left. Do we know what times 6 gives us 24? Yeah, 6 times 4 is 24. And my mouse is not really cooperating right now. I don't write this sloppy in real life, just by the way. So I'm asking, though, about 84. So what do I have to do with these 2 numbers? It's like I drew an area model and I knew 60 and then I added on another 24. And I was trying to find this other dimension, right? So I drew this really quickly. And I knew that this was 60. Yeah, what is going on with my mouse today? I knew this was 6. And I added on 24. Y'all see how it's lagging, right? Yeah, something's crazy going on. Okay, so this was 10, and this was 4. So what's my answer? 14. 14 packs would give me 84. So we actually didn't get to talk about remainders like I thought we would have had time to do, but that's okay. Maybe you can think about how we might have remainders. Let's pretend that number was 88. If it were 88, then that means I couldn't fill a whole nother pack. I'd still have just 14 packs, and then I have some pencils left over. But that's all we have time for today. So I hope you guys have a great afternoon. I'll see you again tomorrow. Bye-bye.